Hello, everyone, and welcome to section 4.8 in Precalculus, Applications and Models. This is another favorite section for students because it just kind of sums up everything we've learned. It's not very challenging. What we're going to be doing is solving right triangles. That means I'm going to give you a right triangle, and you're going to use the trigonometric identities that we've been studying to solve for the missing sides and angles. So as I draw my first triangle here, the only restriction is that it does say that they want angle C to be the 90-degree angle. So we're going to call that angle C. It doesn't matter which angle is A. This time I'll put it at the bottom. Maybe next time I'll put it at the top, just so you don't think it has to be in a certain spot. But here's what does have to be in a certain spot. If this is angle A, then the opposite side has to be side A. And I'll quickly show you why that's true. If angle A is super small, then side A is going to be super small. If angle A is super big, then side A is going to be super big. They're completely related to each other, and that's why they're corresponding, and we give them both the letter A. So you can't just put side A wherever you want to, and sometimes students accidentally put it next to the A, but that's not how it works. So this is going to be side C because it's opposite angle C. And the only thing left is angle B. And therefore, I need side B to be right here, 19.4. So there's a couple different things that you can do to solve these. The first is that if you are missing an angle, then you can just subtract from 90, because you could do 180 minus 34.2 minus 90. Sometimes students do that. But even easier are that A and B are always going to add up to 90. They're complementary because the third angle is always 90. So I don't recommend that you do this much work. Instead, angle B is just going to be 90 minus the 34.2. So I'm going to write down the three pieces that I'm needing over here. I need angle B, I need side A. Notice that they use angles as uppercase and sides as lowercase, and side C. You're always going to be given three pieces of information. It looks like two, but remember, you've been given angle C. And this is exactly how it's going to look on your quizzes as well, where off to the side, I'll put those three with lines, and you'll fill them in. So on this one, my first answer is 55.8. Don't forget your little degree symbol. So now we need to get sides A and side C. And the way that we're going to do that is we're going to know that sine of 34.2 is equal to opposite over hypotenuse. That didn't work at all, did it? Because we don't know either of those. So you do have to choose wisely. Sine is not the best choice. Which function will use this 19.4? Cosine will. Cosine of 34.2 will be adjacent over hypotenuse. Now, again, this is a place where a lot of people go wrong. Your first step needs to be to clear the fraction. So I'm going to multiply both sides by c, and now this is a much easier problem to do. This c cosine looks a little funny. Don't get them confused. 19.4, so to get c by itself, I'm going to divide by cosine of 34.2. So you can just do that straight up in your calculator, and you'll find that c is equal to 23.456. 23.456. So here's a little bit of a dilemma for you. Some students will say, oh, no, I like to use sine. Can I use sine since I figured out angle B? This is true. Angle B is 55.8. So sine of 55.8 would have been opposite over hypotenuse. So if you really prefer sine, you might want to do it this way. Here's the only reason I don't recommend that. If for some reason you typed it into your calculator wrong or did it in your head wrong, and B is not 55.8, then now you're going to get 2 answers wrong. So for everything you choose values for which you actually know them for sure because they were given. That's why I chose cosine. Similarly, let's say now you need to know side. So you found out side C. Now you need to know side A. There are definitely going to be people in this room, and I'm not necessarily against this, but there's going to be people in this room who say, oh, I'll use the Pythagorean theorem now. A squared plus B squared is equal to C squared, and that's how I'll find A. A squared plus 19.4 squared is equal to C squared, and you just found C, so 23.456. I am not against this. You are welcome to do that. However, if you got C wrong, now you're also going to get A wrong. So I want you to look at the problem again. You can use this to maybe check your work to see if you did it right. But is there any way that you can find A using just the 34.2, and the 19.4? There is. You can use tangent. Tangent of 34.2 is equal to opposite over adjacent. Not only that, but you don't have to clear the fraction for this one. So well, you have to clear the fraction, but A is not in the denominator. So I multiply both sides by 19.4. And now, without any risk that I've used a wrong answer to get my next answer, I can figure out that A is 19.4 times tangent of 34.2. And just make sure that your calculator is in degrees when you're doing this. And so the value for A should come out to be 13.184. I was a little sloppy there. 13.184. Okay. And literally, my friends, that is it. So if you would like to try the next 2 on your own, you can. Let me quick write the answers for you. So I always write the missing pieces off to the side. You don't know side B, you don't know angle A, and you don't know angle B. It doesn't state angle C, but from the directions we know that angle C is equal to 90 degrees. So the 3 answers are 24.493. Angle A is 45.585. And angle B is 44.415. So if you would like to try and get those answers on your own, that would be great. But of course, I'm going to do it for you. So I'm going to draw my triangle. And just to show you that I don't have to draw it the same way every time, I'm going to put my C here, but I'm going to put A up here this time. And since A is there, this is side A. It's always opposite. So this is 25. And this is going to be side B, which I don't know. And this is going to be side C, which is going to be 35. So I am going to use Pythagorean theorem this time because I want to get this third side. So A squared plus B squared is equal to C squared. So B squared is equal to 35 squared minus 25 squared. And you can literally type it right into your calculator just like that. And then once you get this number, the thing you want to do on your calculator is do square root of answer. There's an answer button on your calculator that will allow you to not have to retype that in. Just do square root and then find the answer button. And that's how you can make it the most exact. And of course, B comes out to be 24.493. So now I have that, but I'm going to put it in a different color. And I'm going to do that to remind myself that that is something I found, not something that was given to me. So if I only want to use given information to find the angles, I should really stick to using A and C. So how can I use A and C? Well, if I'm looking for angle A, then that would be opposite over hypotenuse. So sine of A is opposite over hypotenuse. And we just learned in the last section that we can use the inverse trig function on our calculator inverse sine of 25 over 35. So in section 4.7, we mostly did ones that were on the chart. But of course, you can use your calculator to do all the ones that are not on your chart, like 25 over 35. An inverse sine of 25 over 35 will come out to be 45.585. And now, last one. So there was 3 things I was trying to find here. The third thing that I'm trying to find is angle B. And again, if I want to stick to the 2 things I was given, the 25 and the 35, now I'm going to use cosine. Cosine of B is adjacent over hypotenuse. So again, that's not one of my known ones. It's not on my chart, but I can use the inverse function on my calculator. And that will come out to be 44.415 degrees. And that's number 2. All right, I have written the next 2 sets of answers for you. So if you think you got the hang of this, it would be so great for you to do this work on your own. But on the outside chance that you need to see a couple more, I'm going to go ahead and do them for you. So my first step is to always draw the triangle and to label all the parts. So let's put B here and A here and C here. Remember, C is always the 90 for this particular set. This is side C because it's across from the angle C. This is side A because it's across from angle A. And this is side B because it's across from angle B, which they gave to us as 54 degrees. So the easiest one to get is angle A because these 2 angles add up to 90. But again, I'm going to put it in a different color to remind you that that is not something that was given to us, and you may not want to use it when you're doing your calculations. Instead, I would use just the 54 and the 15. So my first step would be to say, well, if I want to find A, what's the relationship between A and C? Given 54, adjacent and hypotenuse. So that makes me want to use cosine. So cosine of 54 degrees is equal to adjacent A over 15. And therefore A, clearing the fraction on both sides, making sure your calculator's in degrees, is going to come out to be 8.817. When I want to do B, I could use the Pythagorean Theorem, but instead, because I would have to use something I just figured out and might have done wrong, I'm going to go ahead and look at the relationship between the 54 and the opposite side in the hypotenuse, which would be sine. So sine of 54 degrees is B, opposite over hypotenuse. Again, I'm going to go ahead and clear my fraction by multiplying both sides by 15. And then when I do that, I get B is equal to 12.135. Now, as a little check, you could do 8.817 squared. You can actually use the square button on your calculator for that. 12.135 squared, and see if it comes out to be 15 squared, which is 225. So if you do, then you know you did it right, which is a great feeling. You can hand in your quizzes with confidence. Okay, last one. So I'm going to draw my triangle just a little bit flipped this time so you don't think it always has to be exactly that same way. We'll put C here. And this angle is a little smaller, so I'm going to say A is 8.4. That would make this B, and this side would be A. So 40.5 would be side A, and this side would be side B, and this side would be side C. Always do opposite. So now, again, using just these 2 pieces of information in my right triangle, this is opposite over adjacent. So that would be tangent. Tangent of 8.4 degrees is equal to opposite 40.5 over adjacent. Now, I have to tell you, a lot of people get this wrong because they don't want to just do what we've always done, which is clear the fractions. They think they should be able to do it in one step, but you really can't. clear the fractions. Dividing tangent of 8.4 by 40.5 doesn't solve anything because the b is stuck in the bottom. You've got to get that b on top. So b tangent of 8.4 is equal to 40.5. And now you can divide both sides by tangent of 8.4. Divide by tangent of 8.4. And you get b is equal to, and then you can just type this into your calculator. 0.5 divided by tangent of 8.4. And it's huge, 274.265. And then lastly, I need to find side C. Could use Pythagorean theorem, but I'm going to save that for a check. Okay, this was just a check. So I didn't actually use it to get any information. Instead, I say to myself, well, actually, let me fill this in first. So B came out to be, notice I'm using a different color. I want to remember that this is not something I was given. It was something I figured out. So to get C using just what's given, I have opposite and hypotenuse. So I'm going to say sine. Sine of 8.4 is opposite over hypotenuse. Again, do not attempt to do that without clearing your fraction first. I'm going to convince you of that this year. So C sine of 8.4 is equal to 40.5. And now it's an easy enough problem. Divide both sides by sine of 8.4. And I get C is equal to, you can go ahead and do that on your calculator. And then use Pythagorean theorem if you would like to check your work. 277.240. Another thing that you can do to check your work is to make sure that C came out the biggest. They should always correspond. So notice that C is the 90-degree angle, so it's going to be the biggest. Actually, we didn't figure this out, but if you just subtract from 90, this is 81.6. So look how much bigger this angle is. It's huge compared to 88.4. If I were actually going to draw it, it would be really hard to draw. It would be, I mean, if it were 8.4, it's tiny, 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 right? It's just a little tiny angle. And then this one's big. Think about it. It's almost 90. That's 90. And this angle is 81.6. So do you see that if A is 8.4, A is 8.4, that this is also going to be a tiny side? And sure enough, it's only 40, where this side across from the 81.6 came out to be 274. 274. And then this one is 277, which makes sense that they're pretty close. If you try and draw it even slightly in proportion, then that's another way to say, okay, that totally sounds right. All right, let's try some word problems. So the base of an isosceles triangle, so in case you've forgotten, isosceles means two sides are the same. So the base of an isosceles triangle is 14 centimeters in length. So here's isosceles, and this is the notation from geometry that you used to show that the two sides were the same. And then this is 14 centimeters. And the angle opposite the base measures 86. Find the length of each of the congruent sides. So they want to know x, which is the same on both sides. Now this one does have a little bit of a geometry trick to it, which if you don't remember is going to be very challenging. First of all, you know something's up because we only have been learning about right triangles. For every problem, you're going to need a right 90-degree triangle. So the way you're going to get that is you're going to drop a perpendicular. I don't know if you remember that from geometry, but if you drop a perpendicular in an isosceles triangle, it will always make two equal triangles. So if this was 86, now it's 43 and 43. and then this is 90, and it'll bisect, which means to cut in half the base. So this will be 7, and this will be 7. So you really needed some geometry, need to remember some things from geometry to do this problem. So now they only want to know x. So unlike what we were doing before where we had to find all the different pieces, just x. So what is the relationship between the side opposite the 43 and the hypotenuse? It's sine. Sine of 43 is equal to opposite over hypotenuse. Okay, make me happy. Do you know what to do next? I hope you said clear the fraction, because in that one fell swoop, you literally made this into a problem that many, many people get wrong into a problem that you can do successfully. So x is going to be equal to 7 divided by sine of 43. And so x is going to be equal to 10.264. Make sure you add, when we're doing word problems, you should always look for units. A swimming pool is 20 meters long and 12 meters wide. The bottom of the pool is slanted, so the water depth is 1.3 meters at the shallow end and 4 meters at the deep end. Find the angle of depression of the bottom of the pool. So if you were looking at the pool from a helicopter, you would see this. I'm going to write aerial view. So 20 by 12. That's the aerial view. But it wouldn't show you that how deep it was, except that this would be a darker blue than up here. That would kind of give some indication of depth. So instead, I want to do what we call a cross section. That's when you look at something from its side. So from the side, this pool is 1.3 meters deep at the shallow end, and then it goes all the way down until it's 4 meters deep. We call that a cross section, and this is the top of the pool. The pool's length is 20. And interestingly, the 12 doesn't affect anything. If I were going to draw it, it would be like that. It would be 12 meters. So then now it's like a 3D, not a great 3D, but the best I can do, 3D of this pool. But we actually don't even need the 12. We just need to know the cross section of the pool, which would look like this. Now I am looking for a right triangle. That should always be part of your thought process, is where can I make a right triangle? And I can do that here. If I think of the whole shallow end as going across the entire pool and then the deep being underneath it, then I can draw a line there. And this is also going to have a length of 20. They want to know the angle of depression to the bottom of the pool. Angle of depression always starts at the top line and goes down. So this is my top line. Like it's horizon, it's always going to be a horizontal line. And then it goes down. So like that. So this is the angle that they're talking about. Now, the 1.3 isn't in my triangle. The 20 is in my triangle, but the 4 is not in my triangle. 4 is this entire distance. So how do I get another piece of my triangle? I don't know how long the slant is, but I can find this piece right here by doing 4 minus 1.3, which would be 2.7. And now you have to ask yourself, I know the opposite and I know the adjacent. Which trig function is that? So I hope now you see why we have different trig functions, because all the time contractors and engineers and architects are trying to find different pieces of things. And so depending on which piece you're trying to find, that's which trig function you use. So if they wanted to end up being 4 feet from 1.3 feet, they want to know this angle. That's what trig is for. So tangent of theta is equal to opposite over adjacent. Now, again, this is not on our list. It's not one of our known ones, but that's okay. Last section, we learned how to do inverse functions. And if your calculator is in degrees, then you can go ahead and type that in. So inverse tangent of 2.7 divided by 20 is 7.688 degrees. Which doesn't sound very steep, but it's a pool. I mean, think about it. People walk down it, so you don't want it to be very steep. Let's do another one. A hip roof. So most people really don't know what a hip roof is. Most houses have a gabled roof, which means it looks like this. That would be the roof of your house. But a hip roof is something that you might see on like a gazebo where it looked like this instead, where all the parts of it all came together to form that hip, and then there's two other on the other side. So if you had a bird's eye view at the top of this gazebo, it would actually look like this. So this is normal on a house. Not that there aren't any houses that have a hip roof, but it's much more common for it to have a gable, and this would be called the gable end. But this is called the hip roof. And again, you normally see it on things like gazebos. This is the bird's eye view. So the hip roof is formed of four congruent isosceles. Again, isosceles means that they have the same two sides, which makes sense in this example, with a common vertex that forms the peak of the roof. If each triangle has a base of 26 and a height of 14, find the measure of the base angle. So I'm going to blow up this one piece right here. And it says that its height is 14 and its base is 26. But that means that this half, remember from the previous problem, that if I bisect an isosceles triangle, or if I should say, if I drop a perpendicular, it does bisect an isosceles triangle. So these are both going to be 13. But in this case, they don't want to know that distance like we found last time. This time they want to know what that angle will make to make that hip roof. So I ask myself, which parts am I given in reference to that angle? I'm being given opposite and adjacent. So my trig function of choice is going to be tangent. So tangent of theta is opposite over adjacent. And I go ahead and I plug that into my calculator by doing inverse tangent of 14 over 13, making sure that my calculator is in degree mode. And I will get 47.121. That's the measure of that base angle. And of course, it's the same at every single spot on there. So every once in a while, somebody says to me, why didn't the 247 and 47 doesn't make 90? Remember, this looks like it's flat, but it actually is tilted up. So they don't have to make 90 because they're two separate, they're on an angle. All right, this last one's a little tricky. Don't worry, you can do it. At a point 200 feet from the base of a building. So here's going to be our building. And this building is going to have a smokestack on it. And you're 200 feet away. And the angle of elevation to the bottom of the smokestack. So this angle, and elevation means from the bottom horizon going up. This angle of elevation is 35. And then the angle of elevation to the top of the smokestack, this angle right here, not the little one, but the whole thing, is going to be 53. find the height of the smokestack. So there are two triangles here. One of them is going to be the green one, and that's going to be the one with the 53. And then there's also a red triangle that's also a right triangle. And that one, we know the angle 35. So x is not a side on either one of those. It's a piece of a side, but it's not the whole thing. So this is an example of the fact that sometimes you're going to have to do a little bit of work to get the thing that you want. I want x, but it's not part of either of my triangle. But I can find this side, this whole side over here, let's call that A. And I can find this little side, let's call this B. And then A minus B would give me X. So that's going to be my plan of attack. I'm going to sit there and say, well, I can't find X. It's not part of a right triangle. In chapter 5, or chapter 6, actually, we'll actually find how to do trigonometry without a right triangle, which is really cool. But in this chapter, we're just sticking to all things with right triangles. So when you see this problem again, hopefully you'll remember it. But for a green triangle, I have the adjacent side, and I'm trying to find the opposite side. So I'm going to use tangent. Tangent of 53 will give me that whole A over the adjacent side, which is 200. I clear my fraction. And then I get A is equal to 200 times tangent of 53, which gives me 265.409. 265.409. And now I'm going to do my red triangle. Again, I'm going to use tangent, because tangent of 35 will give me opposite, which is B, over adjacent, which is still 200. I'm going to clear my fraction. Are you getting so sick of my saying clear your fraction? But I hope it's becoming, I really hope it's becoming something that you do easily. And B is going to be 200 times tangent of 35, which is going to be 140.042 minus 140.042, and that will give me my x. A, so this entire distance was 265 minus the 140, and that's going to give me my x. Let me do that on my calculator real quick. Sorry, you have to wait. And I got 125.367. 125.367. What do we have? Feet. Okay, in order to do this last problem, I need to explain something called bearing. Bearing is the acute angle that a path or line of sight makes with a fixed north-south line. So if somebody says that they're going south 35 degrees east, then you start on that first letter. So start on south and then literally move 35 degrees to the east. So 10, 20, 35. So it'd be somewhere right there. Okay. That would be, so if you were a ship traveling, this is the direction that you're going in. That is, and the 35 would go right here. If you were a ship and you said that your bearing was north, 80 degrees west, then again, you're thinking about north, but then you're moving 80 degrees to the west. So right there. So this is where that 80 degrees is. And that would be how you were bearing. So you're almost going west, but you're actually north 80 degrees west. See if you can do that last one. North 45 degrees east. Where is that? So I start at the north-south line, and then I move 45 degrees in the eastern direction. So right there. And you might notice that these look really big. I blew this up so I could see those little numbers. All right. Now, interestingly, that's how ships do it, and most surveying and navigation. But for some reason, pilots in air navigation do it differently. They always measure from north and move clockwise. So for air navigation, they would always start at north and do this angle instead. So instead of giving any kind of things like that, they would just say 145 degrees. I'm bearing 145 degrees. And it would be understood that they were starting at north and moving clockwise. Personally, I mean, if I were a person, I think saying southeast, having that in your description is just fantastic. I could picture that right away. I mean, especially for this next one. For this next one, you'd have to go all the way around to get your air navigation, which would be 280 degrees. So somebody would, if they were a pilot, would say, I'm bearing 280 degrees. It would be the same as somebody who said, I'm bearing north 80 degrees west, which to me feels more descriptive, but it's not my choice. It does work fine if you're going northeast because it's still just 45 degrees. So if you see something that doesn't have the compass points written on it, then just start it north and keep going until you get to that angle. All right, but our problem is going to be a boat, so we don't have to worry about the air navigation. A tugboat is 36 kilometers due north of Lighthouse A. So then Lighthouse B is due east of that. So here's my little tugboat. And I've got my Lighthouse A. And then due east of Lighthouse A, I have my Lighthouse B. And that lighthouse is, I know these drawings aren't great, sorry. The lighthouses are 53 kilometers apart, and the tugboat is 36 kilometers due north of Lighthouse A. So it says, find the bearing of Lighthouse B from the tugboat and the distance. So the distance is definitely easier to find. So this distance, you can just use Pythagorean Theorem. So 36 squared plus 53 squared is going to give me that distance squared. And if you do that math out, you will get 60. You can just do it on your calculator. 0.070 kilometers. Now for the bearing, you have to ask yourself generally, what direction is he going? It says of the lighthouse from. The key word is from. So if you're the tugboat, how are you going to get to Lighthouse B? You're going to go generally south and generally east. You always state north and south first and then east or west. So you're generally going south and then east. And this is the part that a lot of people do wrong. You have to start where you said. So if you said south and then you said east, you need this angle right here. Even if it had been more convenient for you to draw the triangle somewhere else, this is the angle you have to get. And how do we get that angle? So we know opposite and adjacent, which is going to be tangent. So tangent of theta is opposite over adjacent. This is not one of our known angles, but that's okay because we have a calculator. Inverse tangent of 53 over 36 is equal to inverse tangent of 53 divided by 36 is equal to 55.814. So that's what you would put up in here, 55.814. 0.814 degrees. But you have to nestle it in between that south and that east to be given full credit, to have it be correct. If somebody just said, oh, we're bearing 55 degrees, then it would be assumed it was from north. But if you say the directions, the southeast, then you know you're talking about that right there. Okay, so you're ready to do your homework. And in addition to that, there is a chapter review. This is a really long chapter. It's a pretty long review. You're going to want to get started on it, even though you have a whole extra class day for it. Remember that when they ask you to find all 6 trig functions, you're welcome to just find 2. It's a little tedious to always find all 6. And the most important note is that the book's answer for number 19 is wrong. This is the correct answer. So anyway, that's all the notes for today and for this chapter. Have a great day.